Alrighty, hello everybody. It is time for us to look at the topic 1 review. So I'm going to go through these problems and explain how each of these answers work. I don't have the work sitting next to me for once, so we'll see how this goes. If I make a mistake, I will let you know. So for 9, ln equals 45, find x. This is going to be the angle addition postulate. So 3x plus 2 plus x plus 19 equals 45. So that's going to be 4x plus 21 equals 45. Subtract 21 from both here. So we get 4x equals 24. Divide by 4. And we find that x equals 6. So that's the first answer here. Down on the next one, we have RS equals 27, find QS. So we're working a little bit backwards here. If RS equals 27, then that means 12x minus 21 equals 27. So we'll add 21 to both sides. We get 12x equals 48. Divide by 4. So x equals 12. And then to find QS, that means we're going to do 9x plus 12x minus 21. So that's going to be 9 plus 12 is 21 times 12 minus 21, or that's 21 times 11, which is going to be 231, I think. Let me check. 21 times 11. It's going to be 231. Now that I'm looking at my answer key, it says it's 63. So I'm not entirely sure if I've done something incorrectly. Let's see. Well, we'll just go with that for now and go from there. Could be 231, could be 63, and maybe I've made a mistake. We'll come back to that one if we need to. Number 11, using this diagram, if the measure of angle EBG is 60, and again, you've got to trace that angle. So EBG is 60. And then the measure of angle FBG, which is inside of there, is twice the measure of angle EBF. Then the measure of angle EBF is what? So if FBG is twice the measure of EBF, then there's 3 x's inside of that angle. So for number 11 here, we can say 3x equals 60 and divide both sides by 3, and we get x equals 20. So the measure of angle EBF is 20. I'll go ahead and erase this so that we can work on it again. The measure of angle ABE equals 64. So ABE is this angle right here. The measure of angle DBE is how much? All right, so maybe we are working all... no, I see. There's 2 little congruency marks down here. So if ABE is 64, but it's made of 2 congruent angles, then each angle is half of that, or 32. So that's 32 degrees. And then finally, we've got the measure of angle GBH is 28. So here is GBH. It's got 2 hash marks on it. That's 28. So GBC is going to be double of that amount because we have another angle with 2 hash marks on it. GBC is right here. So we're going to take 28 and double it, which is going to make GBC 56 degrees. I will erase that. Number 14, point K is located on a number line, and JK is equal to KL. If the coordinate of L is 23, what is the coordinate of point J? So if we think about a number line, we can actually draw one here. We can say, all right, here's 7 on the number line, and that is K. And JK is equal to KL. So the coordinate of L is 23. So here's 23. What is the coordinate of point J? So there are actually two possible answers for this. First, we need to figure out the distance between K and L. So we would do 23 minus 7. And that is going to give us 16. So there are 16 units in between here. So the thing is, it doesn't say that J must be on the left side here. It could be. We could go 16 more units this way. And if we did go 16 more units to the left and say that that could be J, then that would be 7 minus 16, which would be negative 9. So again, there'd be 16 in between. But it's also possible that J could be on the other side of KL. It could be over here 16 units, and this could be J. And we would do 23 plus 16, or 39, because there would be 16 in between those two as well. So the two possible answers here are negative 9 or 39. Both of them could be the coordinates of point J if JK and KL. Oh, if I'm wrong. If JK is going to be on this side and KL is already 16. So I am giving you too much information because JL is not incorporated in here. So we're going to get rid of the 39. Let's redraw that number line because it went away from us. There we go. So it's just going to be negative 9. I told you this video might be kind of rough because I don't have the answers written down here. Number 15, I have showed what that should look like. If we copy the segment, that means that we're going to take this segment and copy it onto here. I see there's a little arc where I have copied the length here. Then we can make an arc. So start on T with our compass, make an arc up above and down below. Start on S with our compass, open it up to T and make an arc up above and down below. Connect those two lines and create the perpendicular bisector with these two marks for bisector and the square for perpendicular. 16, exactly the same as 15. Number 17, to copy the angle, we start by making one line. Then we draw an arc from both sides of our original angle. We draw that same arc through through the one side we've drawn here and then going upward. Then we'll take our compass, set one point on the edge of our original angle and set the other point on the other edge. We'll use that distance and we'll measure the same distance over here, swing an arc, and then find the copy of the angle by drawing that final line. Once we have our angle copied, then we are going to make an arc. So compass points here and here, make an arc outward. Compass points here and here, make another arc outward, and connect those together to create that bisector, and put two little arcs inside that angle to show that it is bisected. Same thing with number 18. Number 21 through 24, find the midpoint and length of each segment. So there's quite a lot of work to do in this one. I will go ahead and do 21, and then I will show you the answers for 22, 23, and 24, because all of these will be the same type of problem. So 21 here, we'll find the midpoint first. And so we'll need to know what the coordinates of E and F are. And it looks like E is at negative 3, 2, and F is at 1, 3. So then we can go ahead and we can say, all right, the midpoint between those means I'm going to add the x's together, negative 3 plus 1, divide them by 2, and add the y's together, 2 plus 3, and divide them by 2. And so what I end up with is negative 2 over 2, which is negative 1, and 5 over 2, which is 2.5. So the midpoint is negative 1, 2.5. The distance is going to use the distance formula. So I'll put in the distance formula here. It's going to be the parentheses x2 minus x1 squared. I can use either coordinate as x2 and x1. So I'm going to write 1 minus negative 3 squared plus y2 minus y1 squared. That's 3 minus 2 squared. And I'll go ahead and I will simplify and solve here. So that's going to be the square root of 1 plus 3, which is 4 squared, plus 1 squared. And that's going to give us the square root of 16 plus 1 gives us, finally, the square root of 17. We can change that into a decimal if we want to, but that works as well. The other answers here are that 22 has a midpoint of 3, 2, and a distance of the square root of 20. 23 here has a midpoint of 3, 0, and also a distance of the square root of 20. And 24 has a midpoint of -1, 0.5 or 1/2, and a distance of 5. Let's keep going. What are the coordinates of a point 2/5 of the way from H to E on the grid? So we'll look where H and E is. H is at 1, -1, and E is at -3, 2. So we're going to find 2/5 of the distance of the x coordinates. So 2/5, and we will do that by taking the E, the x coordinate of E minus the x coordinate of H. So that's going to be -3 minus 1. And we'll do the same thing for the y's. We'll take 2/5 of the change in the y coordinates. So the y coordinate of E minus the y coordinate of H. So that's 2 minus -1. So we find out that 2/5 here would be 2/5 of -4. And over here it would be 2/5 of 3. And I'm going to go ahead and turn those into decimals when I do the multiplication there. So 2/5 of -4 is going to be -1.6 on the x's. 2/5 of 3 is going to be 1.2. So we'll take our original coordinates of H, which are at 1, -1, and we'll say, all right, I've got 1 minus 1.6, and I have -1 plus 1.2. We end up with -0.6 and +0.2 as the coordinate point we need. Number 26, Sadie models her neighborhood on a coordinate plane so that her school is at 8:12 and the store is at 14:3. What are the coordinates of a point halfway between the school and the store? Of course, we're just finding the midpoint for the halfway point here. So we're adding together our x coordinates, 8 plus 14 over 2. We're adding together our y coordinates, 12 plus 3 over 2. So this is going to be 22 over 2, or 11, and 15 over 2, or 7.5. And those will be the coordinates of that midpoint. Next, we want to write down what is the law of detachment. Now, the law of detachment is the one that says if our original conditional, P leads to Q, and the hypothesis of that original conditional, P, are both true, then the conclusion of the original conditional, Q, is true. Right? The law of syllogism is the one that tells us if we have two conditional statements that are repeated in the middle, then we actually have one big conditional statement. We say if we have two true statements, P leads to Q and Q leads to R, are true. So we have two conditional statements with a repeat in the middle. Then we can drop out the repeat and we can say then P leads to R is true. Perfect, perfect. Now we've got a sequence one. Draw the next two terms in the sequence. So it looks like term 1 has 5 dots. Term 2 has 4 plus 4, which is 8. Term 3 has 5 plus 6, which is 11. So it looks like we're adding 3 each time. So the next term, if we were to draw it, it would have, let's see, 4, 5, 6 going down, 2, 3, 4, 5, 6. And it would have 8 going this way, 3, 4, 5, 6, 7, 8, which means that it would have, depending on how you looked at that, it would have a 5 times 2 rectangle on the top plus 4, which would be 14. Or you could draw it, or you could count it a different way, but it would have 14. And the next term would have 7. 1, 2, 3, 4, 5, 6, 7. And then it would include a 5 by 2 rectangle. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And that would have 17 dots. So if we wanted to say explain how to find the 6th term, we could say we want to add one more dot to the flagpole. Add one more dot to the flagpole. And 2 more dots to the flag. All right. When we want to create a formula to find the number of dots in the nth term of the sequence, I'm noticing that I'm adding 3 each time, which makes this formula a linear function because it has a slope of 3. We're adding 3 every time. So we've got 3n, and then we say, well, how many more do we have? So in my first term, my term 1, I have 3 plus 2, which is 5. In my second term, term 2, I have 3 times 2, which is 6, plus 2, which is 8. And my third term, I have 3 times 3, which is 9, plus 2, which is 11. So it looks like I've got 3n plus 2 dots in every term of the sequence. Now we're doing more terms in sequence using inductive reasoning to find the next 2 terms in each of these sequences. So we've got 1, 2, 6, 24, 120. Looks like we are going upward here. We're doing times 2, times 3, times 4, times 5, which would be the next one would be times 6, which would be 720. And then times 7, so 720 times 7, which would be 5,040. All right. The next one, it looks like we are going plus 2, plus 3, plus 2, plus 3. So we're going to add plus 2, which would be 15, and plus 3, which would be 18. Number 29, we've got 2 to 5, so that's plus 3, plus 4, plus 5, plus 6. 20 plus 7 is 27. 27 plus 8 is 35. Number 30, we've got plus 4, plus 4, plus 4, plus 4. That's simple. We add 4 to get 37 and 4 more to get 41. All right. Down here, we want to find a counterexample to disprove each statement or support it with 4 examples. So 31 says all triangles have 3 congruent angles, but that's not true. So we could show with an example that that's not true. So for example, in a right triangle, I know that that's a triangle, but it doesn't have 3 congruent angles because one of them is 90 degrees. So that would be a counterexample. Number 32, if p is an even number, then p plus 12 is even. This one seems true, so I could try things, right? 2 is even, and 2 plus 12, which is 14, is also even, right? 4 is even, and 4 plus 12, which is 16, is also even. 10 is even, and 10 plus 12, which is 22, is also even. 54 is even, and 54 plus 12, which is 66, is also even. So that one seems true. All right. Number 33, explain why only one counterexample is sufficient to disprove a statement, but one example is not sufficient to prove a statement. So this has to do with how we define true or false, because a true statement must always be true. I'm going to write this. A true statement must always be true. So one counterexample will show that it's not true. So one counterexample will show that it's false. But you can't ever show that all the possible examples are true. So we'll write that. But you can never show that all the possible examples are true. So it's not possible to prove that the statement is true that way. So it's not possible to prove that the statement is true that way. All right. Number 34, the table shows how much Jack saves in his bank account each week. At this rate, how much would he save on week 10? So we can find the, the difference in the savings here. So we could take like 350 minus 175 and say, oh, we're going up by 175. And we're going up by 175 in number from 2 to 3, plus 1.75. We're going up by 175. Looks like every time. So if we're thinking about week 10, we're going to say, all right, so that's going to be $1.75 times 10. And I know that because at week 0, if we subtracted 175, we would have $0 in savings. So we started at 0. So this is going to give us $17.50. All right, we're writing some things here. For each statement, write a conditional and the converse, inverse, and contrapositive. So it actually gives us the statement, but it's not a conditional yet. We need to change it into the conditional, which is the if-then statement. So our conditional statement would be, let's see, if a number is a multiple of 4, then it is a multiple of 2. If a number is a multiple of 4, then it is a multiple of 2. That's true, by the way. Then we would need to write the converse. So the converse is when we switch the hypothesis and conclusion. Say, if a number is a multiple of 2, if a number is a multiple of 2, then it is a multiple of 4. Coincidentally, that's not true, but we don't need it to be. Then we have the inverse, which is where we negate the hypothesis and negate the conclusion. So if a number is not a multiple of 4, then it is not a multiple of 2. And then finally, the contrapositive, where we switch the hypothesis and conclusion and negate them both. If a number is not a multiple of 2, then it is not a multiple of 4, which of course has the same truth value as the conditional, so that one is true. 36 is the same way, so I'm actually going to write this after I'm done with the video to save time, but it's got the same structures as the one above it. Find the truth value of each conditional, explain your reasoning, or show a counterexample. So the statement is, if a number is less than 4, then it is prime. So to show that it's a counterexample, that means that we would need to state that we found a number less than 4 that is prime. And there is a number less than 4 that is prime. So we can say false, because 1 is not a prime number. 1 is less than 4, but not prime. 2 and 3 are prime numbers, but 1 is not. Number 38. If 3x minus 6 is less than 14, then x is less than 8. Well, we can solve this to find out if that's true or not. So we can add 6 to both sides. 3x is less than 20. Divide both sides by 3. And so we have x is less than 20 over 3, which is like 6.6 repeating. And if x is less than 6.6 repeating, then x has to be less than 8. So any number less than 6.6 must be less than 8. All right, and that's all we need there. Down here, we've got the 1-6 stuff to look at. So assume that the given information is true. If AB equals BC, then DE equals 2 times AB. AB is 6 and BC is 6. What can you conclude? So if AB is 6, we could substitute that in here. 6 and BC is 6. Well, we know that now this information makes the hypothesis true. By the law of detachment, if the hypothesis is true, then the conclusion is true. So then DE equals 2 times AB, which we know to be 6. So the conclusion is that DE equals 12. All right. Number 42. If it is a sunny day, the water park is filled with people. If the water park is filled with people, the lines for each ride are long. Use the law of syllogism to write a true conditional. Well, the conclusion of my first statement is the same as the hypothesis of my second statement. So I can use the law of syllogism to take out that statement and just use the first hypothesis. If it is a sunny day, and the last conclusion, then the lines for each ride, whoops, that's not what I needed to do. There we go. For each ride are long. And I've put that together using the law of syllogism. Number 43, an advertisement says, if you use their toothpaste for more than a week, you will have fresh breath. You use the toothpaste 10 days. If the advertisement is true, what can you conclude? Well, we have information that makes the hypothesis true. We've used the toothpaste for more than a week. So based on the law of detachment, we can conclude that the conclusion is true. You have, or you will have, fresher breath. And that's all there is to it. Let's look at the 1-7 and 1-8 stuff. Oops, one more here that got cut off. This belongs with the above. Find the truth value of each conditional, explain your reasoning, or show a counterexample. So a cafeteria only offers pudding on Tuesdays. Use this fact to write a biconditional about pudding. It does not go with the ones above it. So we can write, because it says only offers pudding on Tuesdays, we can say if the cafe, nope, not if then, right? Because we need to use if and only if. So the cafeteria offers pudding if and only if it is Tuesday. So every biconditional uses if and only if to connect the two sides. Find the value of each variable and then measure of each labeled angle. We've got some vertical angles here, so we can make equations. We can say 3x minus 6 equals 2x plus 22, and then solve that. So we've got plus 6, x equals 28. That's part of my answer. And we also have to find the value of each labeled angle. So I've got 2 times 28 plus 22 is going to be 78 degrees. So each of these are 78-degree angles. Down below, I've got 2x plus 32 equals 3x minus 5. And to solve that, add 5. 37 is my x. And to find the value of the variable, I've got 2 times 7 plus 32. Doing this one at school. So 2 times 7 plus 32 gives me 106 degrees. So 106 degrees as well. All right. Ooh, got a proof here. Write a proof. Given the measure of angle TUV is 90, prove that x equals 12. So we've got a lot to do here. Let's go ahead and write our T-chart. I'm going to kind of make it really long here because I know I'm going to need quite a bit of space. So I've got statements, and I have reasons. And I can say, all right, statement number 1 is going to be easy because it's the given information. The measure of angle TUV equals 90 degrees. And the reason is given. 2 is going to be a little bit harder. I'm going to say, all right, how do I go from here? Well, I'm looking at the measure of angle TUV, and I see that it's made of 2 smaller angles. And I see one of them is a y, and I have a y over here as well. So I'm thinking if I can figure out what y is, then I can work on this side. And that's going to help me out. So I need to separate my big angle into 2 smaller angles. I'm going to do that using the angle addition postulate. So I'm going to say the measure of angle TUW, one small angle, plus the measure of angle WUV, the other small angle, equals the measure of angle TUV, the large angle. And I'm doing that using the angle addition postulate. All right, step 3. Now I have variables that I can put for the measure of angle TUV. I know that that is y degrees, plus the measure of angle WUV. I know that is 42 degrees, equals, and I'm going to use my given information, equals 90, because I'm substituting that in. So each of those gets substituted in, so I'm using substitution. All right, now I can find what y is. I can subtract 42 from both sides and find that y degrees, or y equals 48. And I'm doing that by subtracting, or subtraction. All right, once I know that y equals 48, I can go further. I can look at the other diagram and I can say, hey, I know that construct. I know that those are vertical angles. So I know that 4x equals y because of vertical angles. Again, you may be able to put some extra steps in here if you want. You might have extra steps in your proof, and that's fine. But by vertical angles, I know those angles are the same. So 4x equals y by vertical angles. And I know y. Y is 48. So step 6 is going to be 4x equals 48 because I'm substituting that in. So I'm using substitution. And finally, now that I know 4x equals 48, I'm going to divide both sides by 4 and get x equals 12. And I did that, like I said, by dividing both sides by 4, so by division. All right, and that is all there is to that proof. And again, yours might be different. That is okay, as long as you check with me and make sure that it works. Finally, 47, write an indirect proof by proving the contrapositive. So first of all, what is the contrapositive of this statement? We have given and proof. So the contrapositive would be to go backwards. The contrapositive would be if the negation of the conclusion, x is actually equal to 12, then we would use the negation of the hypothesis, Gj is not equal to 48. So to start our proof by contrapositive, we assume the negation of the conclusion. So assume x is equal to 12. Then we have to show that if x is equal to 12, Gj is not equal to 48. So we'll assume x is equal to 12, which means GH equals 2 times that, or 24. So this means GH equals 24, and HJ is just x, so HJ equals 12. And I know that using the angle, or using the segment addition postulate, GH plus HJ equals GJ. I know that for sure. So if I substituted in 24 and 12, GJ would be 36. So it's not equal to 48. So GJ does not equal 48. I've just proven the negation of the hypothesis. Therefore, I've proven the contrapositive. So since I've proven the contrapositive already, therefore, by proving the contrapositive, the original conditional must be true. Now that I've shown that the contrapositive is true, I know that the original conditional is also true. Whew, that was a long one. If you've got any questions, let me know and I can help you out. Or if you think I made a mistake, also please let me know and I can fix it. All right, have a wonderful day.